Hello friends, welcome once again to this video among the Pixlpal tutorial series. In this particular video, we will be talking about how to make use of the rotary encoder of the Pixlpal device. And by rotary encoder, I mean this knob we have on the device. It can perform two functions. Either you scroll, no, rather you spin the knob either left or right direction, or you can turn the knob into a button where you click and have actions performed by the Pixlpal. We have an example demonstrating this already. The example have been implemented, so we'll just go on and walk through the example and how to get the APIs set and make use of this. Within the same tutorial, we will show how to make the buzzer of the Pixlpal to sound a beep or multiple beeps based on user requirements or developers design. Equally, we'll show how you can use the status light, make the status light show a particular color. And what I mean by status light is this LED at the very top of the Pixlpal device. So we'll dive right into it, starting off with the encoder example, which can be found among the example apps directory. So I have the app implementation open on screen. It follows the same template as all Pixlpal apps. However, we introduce two new functions and one statement while initializing the app. As was mentioned, for C and C++ programs, if you are using a function within your code, that function has to be, the signature of that function have to be declared at the top of your program. This is known as function prototype declaration. So for your button, there's a particular function that gets called, or you can take it or think of it as a callback function. And it has this signature specified by this example. This is the function name, and this is the parameter or signature of the function. It receives a variable of type button event, and whatever the action when a button is pressed is contained within this button data variable. So you declare that function at the top of your program. Similarly, for the rotary encoder, depending on what direction you spin the knob, this callback function is called whenever an action is taken using the rotary encoder, and we have the function signature here. A variable of type rotary encoder rotation is sent, and the direction is specified in this variable direction. The rest are the usual Pixlpal app layout. Now, during initialization, you would need to register these functions. Now, registering these functions require they to be in a specific order. The button comes first, which is this callback function. Then the rotary encoder comes second among the parameters, while registering the callback functions for your rotary encoder input device. Now you can see the function body, or rather the API name or identifier, MTB app set EC11. What this simply implies is the uh, the technical name for the type of rotary encoder that is designed within the Pixlpal or used within the Pixlpal. You can look that up on Google, rotary encoder EC11, and the image of the component will be shown to you. That's why the function identifier carries that name. The rest is similar as we've seen, app initialization. Now, just for the purpose of user convenience or interaction, we included a fixed text just to indicate that the application currently running is the Rotary Encoder and Buzzer app. I will just include the status lights over here. Rotary Buzzer and status lights app. Okay, that wouldn't contain. I'll just take this out so the text can appear better. Okay, and yeah. So let's use the symbol and so it appears differently. The rest, as I mentioned, is the same. We enter our loop. Upon exiting, the app is cleaned up before final exit. Now, the functions we specified here, the signatures we specified at the top, so they can be used by the app task function. Those functions have to be defined. So they are defined at the bottom of the program after the implementation of the task, the app task function. So the callback functions must be defined in this manner. You open the function body. Upon the first set of instruction is a switch which decouples the button data to specify what type of action was carried out using the button. The very first case we have when the button is released. Of course, before its release is first of all pressed. If it releases, whatever you specify here gets fired. Here we leave it empty. Now this is for button press. For every single presses or press, this the statements contained within the case and the break statements gets implemented at runtime. We have long presses that goes above a second, up to 2 seconds. You get a particular statement within your program executed. You can equally find out how many clicks. You can make multiple clicks and have a particular action executed. For instance, if you click twice in quick succession, which is case 2, the count becomes 2. Case 2 fires and you have a particular action implemented. So just using button clicks, you can implement as many as 3 to 5 different functions depending on the manner or pattern with which the button was clicked. Now this case 1 will be similar to just button press. So that implies the button was pressed once. So we have this blank, we have 2 presses, 3 presses, and we indicate this by different beep sound, which we would explain. Now to make the buzzer of the Pixlpal to give off sound, you don't need any special configuration or API. What you simply do is you call this do beep function, specifying the type of beep you want giving off. This is an enum. a C or C++ enum specifying different types of beep sound you can obtain. I'll go to the definition so you can see those that are available. We have beep 0, beep 1, 2, 3, as well as click beep. At your free time, you can test whichever you want. Now, just to demonstrate, so it doesn't appear only when the button is clicked, we'll get a beep. I would copy this do beep within the app body. Just before the loop, we should have a beep sound after the encoder and buzzer app text have been printed to the screen. So that is it for the callback function implementation for the encoder app. The very next is the encoder function. We've talked about the button. Now for the encoder, it's pretty simple. Using the same signature as specified in the prototype declaration, you implement the body of the callback function. Now you have basically two directions. Now for every turn of the pixel of the rotary encoder, you get a particular action clicked, or you get a particular action executed based on the direction. You can either have a rotation that is clockwise or a rotation that is counterclockwise. Now we have simple click beeps to specify that the rotary encoder is being interacted with, just to actually indicate the direction of rotation. We'll be printing out some messages to the console. So I would use the C statement. Okay, this is print if. Okay, sorry, print if. This for clockwise direction, and this is for counterclockwise, or rather, this is clockwise and this counterclockwise. Okay, yeah. So we would go ahead and compile the program, and then we execute. In order to execute from the main, I would copy this app, which we would, okay, this, and then this. So we can execute it from the main function upon starting the Pixlpal. So I think we are good. I'll go ahead and compile and flash. We can then monitor after successfully flashing the device. Okay, we have a successful compilation. Flashing is ongoing. You can always monitor the success messages or error messages from these prompts that fires off at the bottom right of your screen. Okay, flashing is almost done. Okay, we have 100%. Initialization in progress. Let's look at our app once again. Okay, I believe you heard the buzzer sound. It's this beep 0 that got fired just while the app is executed. The firing comes soon after the text encoder and buzzer app was printed to the screen. Now we'll go ahead and interact with the rotary encoder to confirm that what we've implemented is correct. I'll start off by rotating the rotary encoder, after which we'll attempt pressing the button. So you can see I'm rotating clockwise. The number of times I rotate, okay, sorry, counterclockwise rather. Now clockwise. And for every rotation, you can hear the click beep. So you can trigger particular actions. One action we implement with the rotary encoder is adding or reducing volumes for apps that give audio output. However, in your case, it could just be any action. Now for the buttons, I would go ahead and click a single click. So we have a particular beep given, which is a beep 0, similar to that which was fired at the starting of the app. I will double click so we can get beep 2 fired. You can, if you listen to the 3 buzzer sound, I'll do that again. I will double click once again. Now the first click causes beep 0 to fire. The second click causes beep 2, which is a double beep sound. Now listen. So that's it about encoders and buzzers. Next, we'll just quickly touch on changing the status light. Now, changing the status light is usually reserved for system changes, such as when we get internet connection, or when we get Wi-Fi connection, or when we lose these. However, in your particular case, you may absolutely need to use the status light to indicate an action. In that case, what you simply do is make use of the APIs for status lights. Now, the API you use for that is, now I would implement it within the rotary encoder. Okay, mtb underscore set status light RGB LED. Okay, let's give this purple for clockwise rotation. Now for counterclockwise, we'll set a different color. Let's give this a green. Then we compile and flash. So in this case, we would have the status light change as well as the debug statement printed out. We equally have the beep give off sound. Currently flashing is going on. Our program compiles correctly. Let's give that a few seconds. Okay, our program is initializing. It should execute any moment from now, starting off with the beep we specified here. Okay, that has fired. Now let's check our status lights. It's currently on yarn color. I would rotate and we'll see the effect. So I'm rotating clockwise and we have purple color. When we go counterclockwise, we have the green color. Clockwise purple, counterclockwise green. So that will be it for this demo of the buzzer, the rotary encoder, as well as the status light APIs. Thanks for listening. I'll see you guys in the next one.